The next topic that falls under the quantitative observations category is a topic known as significant figures. Now, that seems to be a pretty dramatic word for something that's actually pretty simple of a topic. So, what is a significant figure? Well, a significant figure is an important number inside of a measurement. Sometimes not all the numbers that we write down seem to be important. So significant figures is a set of rules for determining which one of those numbers inside of a recorded measurement are actually important. And instead of really thinking about it like being important, I want to really think about that more like the ones that are actually measured. Like not just placeholder stuff, but the ones that we actually took the time to read off of the scale. I want to give you a little bit of an example. So let's take a look at this number. I'm immediately drawn to the 2 and the 5. Well, why would I have taken the time to write down that 2 and that 5 unless they were probably really written on a scale somewhere? So in my mind, these look to me like they're the certain digits inside of the number, which means then that the single digit that falls behind it must be the estimated digit. And although it wasn't printed on the scale, it's still important because I meant to write that down. Well, then there are all these other digits and these numbers. What are these digits? Why are they even there? If we didn't measure them, where did they come from? So they're not measured. They're simply placeholder numbers. In this system of rules, we would consider these to be not significant, whereas the 2, the 5, and the 0, those are all significant digits. That 2, the 5, the 0, we actually measured them. None of the other ones we did. So what are these rules in general for determining what is and is not a significant figure? Well, first of all, you can consider any number between 1 and 9 to be significant. These would have been numbers that were legitimately printed on a scale. You don't just accidentally write down a 7 somewhere. So we would consider them to have been on the measurement tool and therefore been significant. Which leaves us only one type of number left over, and that's zeros. Unfortunately, the rules for zeros do vary. In fact, there are 4 different types of zeros that we need to consider, and it depends on where they fall with respect to a non-zero, 1 through 9 number. Well, first of all, there are the numbers that lead up to a non-zero number. Now notice it doesn't matter what side of the decimal point these zeros fall on. They are to the left of that 2. That's really the most important part. Now, leading zeros are considered to be placeholder zeros. They're never numbers that we would have taken the time to measure out. Therefore, we would consider them not to be significant. A second type of zero, zeros that fall between 2 non-zero numbers. And it doesn't matter how many of them you have, as long as there's a non-zero to the left and to the right, it's considered to be a captive zero. Now, in this case, the number 2002, we took the time to measure the thousands place. We took the time to measure the ones place. What do you think the odds are that we actually meant to measure a 0 in the 100s place and a 0 in the tens place? I'd say pretty good. So these are zeros that would indicate we actually measured them and therefore are considered to be significant. So captive zeros are numbers between 2 non-zero digits and are considered to be significant. The final type of zero is called a trailing zero, and it depends on whether or not they have a decimal place. So you can see there's a distinct difference between these two 500s. There's 500 and then 500.0. Now, to me, the reader of these numbers, 500 without a decimal point communicates a lazy author or somebody who didn't really mean to record with the precision that the second author had. That to me could mean 500-ish. That might be 479. That might be 523. I don't know because there's no decimal point there. There was no care written down with this measurement. I don't know whether or not those zeros were actually measured. So in this case, those zeros are going to be considered not to be measured and therefore not significant, more like a placeholder style zero. The second type of zero, the one with the decimal point, That communicates to me that the author really took the time to measure it all the way down to the ones place and give me an estimated digit in that tenths place. So if these are actually measured with care and authored with care, then we need to consider them to be significant zeros. So let's get into another example problem. Here's just a random number. Let's go through and analyze this number for how many digits in this number will actually be significant. Well, the easiest ones to pull out immediately would be the non-zero numbers. Of course, these are going to be significant. So we at least have 3 significant digits inside of this number. Now let's consider the zeros that fall to the left of the 2. So these are leading up to the 2. These are placeholder style zeros and are not considered to be significant. Leading zeros are never significant. Well, what about those 2 zeros that are sandwiched between the 2 and the 3? Again, if you're stuck between 2 non-zero numbers, somebody probably measured them, and captive zeros are considered to be significant. The third and final style of zero falls at the end of the number, called a trailing zero. There is a decimal point somewhere inside of that number. Therefore, that zero has to be considered to be significant. So in total, we would say that this number has 6 significant figures. So this screen has some sample problems for you to try out on your own. I would advise getting a pencil and a paper and jotting down how many significant figures you feel are in each one of these numbers. Then hit pause, give it a couple minutes, figure them out, then resume the video and I will show you the answer key. So here are the answers to the significant figures question. You might want to hit pause so you can take a look and see all the different numbers here. And remember, if you have questions about determining the number of significant figures, you can always come in for some help.